Hey guys, we're going to do a quick overview on a statistics lesson. We got some definitions here about 3 different statistical methods for gathering data. So I just wanted to define each of these for you. And then we're also going to go into a little bit of, once you have figured out the design of your experiment, how you might sample your population. And those are the major key topics that will be on your EOC. In terms of statistics. So first of all, let's start with just defining an observational study. Essentially, you impose no treatment, meaning you don't have a control group, you don't have like if you think back to an elementary school science project, you don't have one group where you let's say you had plants, and one plant you put in the sun, one plant you put in the dark, and one plant you played classical music or something. That would be the treatment that you did differently to each plant. In an observational study, that doesn't exist. You just go into nature or you go into a lab and you observe what's happening with your particular samples. So you impose no treatment, just observe and take notes. Typically, this is not a good design for something that you are wanting to replicate or something that you're wanting to describe a larger population. So you can't, for example, observe, maybe back to the plant example, that your plant grew better listening to classical music and then expect that to always happen with every single plant. Observational studies have their uses, but describing a larger population with your results is not one of them. Okay, the next thing that we often see whenever we gather data is a survey. A survey can be random, doesn't have to be random, but most of the time it is random. So random members of a population are asked a question. Typically, you would ask everyone, but doesn't have to be. If you ask everyone, then more likely it's called a census. But when you have a survey, you might pick out maybe 5 members of your class to ask them what their favorite music is, or maybe you would ask the first 10 people that walk past you go into the bus what their favorite fast food is, that kind of thing. So a survey can be random. It doesn't have to be. There's particular things you would want to set in place if you were going to use that survey data statistically. And that's what we'll get to in the next note sheet, is how to keep your data gathering random so that it can be used to describe a larger population. Okay, and lastly, we have an experiment. An experiment is what you're used to doing in science, where you have at least 2 groups with different treatments being imposed on them. And by treatment, again, we just mean something's done differently. So if you had 2 different tests that you were taking, maybe you studied in a quiet room with the curtains drawn, no music, no phone for one test, and then for the next test you studied in the middle of Starbucks with your AirPods in, and then you compared the 2 results on your test. Doesn't have to have a control group, but a lot of times that will include what's called a control group, where you don't change anything so that you have a standard of comparison for your results. All right, so with those 3 things, I'm going to ask you to read through some scenarios, and I made it digital, so you'll see that on Canvas. I'm going to ask you to read through some scenarios and just determine whether it would represent observational study, survey, or experiment. All right, the second part of our note video here is going to be if you do decide to do either a survey or a experiment, how are you to make sure that the sample that you pull from your greater population is truly random so that your results are valid? There's many studies that are done that the results mean nothing. So maybe one of the things that you're used to is anytime you're using an app or a lot of times websites or things, they'll ask you to rate your experience. How often do you really click on that, right? So like the people that respond to those are the people that have the strong opinions. They really, really hate it or they really, really like it. So that's called self-response, and surveys like that are not valid in any way, although they're the easiest to give. So if you truly want to be mathematically valid with your results, here's the 4 ways that we might set things up. So first of all, let's just talk about what a population versus a sample is. So you kind of have a visual here. Your population is your larger body that you're wanting to describe with your data. So it may be the population of the United States. It could be the population of North Carolina. It could be the population of your high school. Whatever the larger body is that you're wanting to describe. Out of that population, you then take a small number of people that are more manageable for you to survey or do an experiment with, and that's called the sample. You want to be careful with how you select those people. You want to have some systematic way of picking them so that you try to make sure that they are truly random and that they describe all parts of your population. So, for example, if your population was the state of North Carolina, you'd want to make sure that you included all ages, all races, all maybe religions, all genders, things like that, to make sure that your survey would be able to describe the larger group. So if you want to just define here, sample is a group. I think I've put the wrong thing. Excuse me. A population is a group from which a sample is selected. Or chosen. And then a sample is a part of the whole. Okay, so then we have 4 types of samples. Some are better than others, and I tried to give you a little diagram at the bottom that kind of helps you remember the different types. First of all is the one we talked about with the apps, or if you have like something on the radio they want you to call in, or like if you're on Instagram and somebody has a poll up, that's self-selected because you get to choose whether or not you want to answer, and there was no method, rhyme, or reason for how you pick them. So no method of selection, just anyone who chooses to participate. This is not your best option because, like we said, generally you're only going to get the people that have a very strong opinion for or against something. Okay, the next one, which is a pretty good method for picking people, is called systematic. And essentially what you do here is you choose every nth member of your population. So let's say you had a whole list of all of the students in your school and you wanted to choose, you had an alphabetical order and you numbered them, and you wanted to choose every 20th person to survey, or every 5th person in your class to survey if you had a list of all their names. So that nth just means you choose what interval you want to pick from. This is much better than self-selected. However, it's not the best because you don't necessarily hit every single subgroup of your population. Okay. The next one you never want to do, which is a convenience survey. That's asking people closest to you and most convenient to you. So you ask the people that sit next to you in class, or you ask your family, or go to the grocery store and you ask the first 10 people that walk in the door. Um, that definitely doesn't guarantee you randomness. The only true way to choose a sample is a random sample, and generally that's going to be putting numbers in a hat and pulling out names, or going through a list and numbering them and then using a random number generator to pick out random people. So I'm going to put truly randomizing choice of participants. Whenever you're given a survey from the school, I think it's called the OCR, Office of the Civil Rights Survey, they put all of the names into a computer and it randomly generates who takes that survey. That's how they do it for your parents too. So that's the only true way that you're going to get data that you are sure has every subgroup from your population in it. All right, and then at the bottom here where it says paste 2 examples below of each type of sampling method, again, I made that digital for you so that you don't have the capability of cutting and gluing on the computer. And so it's just going to give you a scenario, and it's going to ask you to identify which sampling method of these definitions you feel like it meets the best. So I hope that helps you understand a little bit about sampling methods.